Good morning. We'll start session 7 on the chapter Is Matter Around Us Pure? So in our previous sessions, we've been discussing about how to separate the components of mixture. Right from filtration by the basic easiest method, then we understood about centrifugation, we understood in yesterday's class funnel method and sublimation. Now in today's class, we will study chromatography. Now what is chromatography? Chromatography is a technique of separating the components of colors. Yes, what type of colors? Now the colors in dye. What is a dye basically? Sometimes we dye our clothes, right? Yes, it is that dye what I am talking about. So chromatography is a technique of separating the components from the colors. Now here, this method is used to separate the solutes in which dissolve in the same solvent which is different in solubility. That means, suppose if I take, now solute is nothing but a color which I take, and if I dissolve that in water, that is in the same solvent but difference in solubility. Difference in solubility means the component which has a higher solubility will rise faster. It is quite difficult to understand by these terms. This chromatography is only understood if you practically try this out at home, and this is possible to a level. Now what actually is the aim? Try to understand. It is used to separate the solute, that is the component color what we take here. Solute is nothing but a color what we choose, that is dye, for example, which dissolves in the same solvent. That means dye is a combination of several, dye is a combination of several colors, say for about black, blue, green, right? So we want to separate those components which dissolve in the same solvent, water. Difference in solubility. Now difference in solubility, for example, if I take some paper, if I just take if I take a sketch pen or a colored marker, if I put a dot on the paper and dip that paper in the water, what will happen? That paper should be of the quality which can absorb water. It is not our usual paper what we use. Laboratory wise, we can use filter paper. You can see the color being spreaded or the color being raised. Whichever color raises, that has the highest solubility. So what is our aim here? Separation of dyes in a black ink, that is in a different colors in a dye. That means colors which are more soluble in water rises faster. Basically, how is this experiment carried out in the lab? So what we do is, we take a strip of a filter paper. Usually we use a filter paper in the lab. In case if you don't have a filter paper, try to use any paper at home which can absorb much water. I think even tissue paper also can act for some time, right? So when we take a filter paper, we just draw a mark on the filter paper. Then what we do is, we put a dye here, colored dye, okay, which you will not come to know which color it is. It is just one color. We put a dot of that particular dye. Now what I do is, I take a beaker where I have dipped it in it and I will fill water. So I will fill water till here. Now what will happen? As the filter paper is getting wet, so slowly the water rises, correct? The water rises. Now when the water rises, it touches the dye, right? The minute it touches the dye, what is the combination of the dye? For example, now whatever dye I have chosen, it has a combination of blue, green and red we'll consider. Fine. It's a combination of a blue, green, red. So the minute the water touches the dye, what happens? The color which has the higher solubility will rise faster. What do you mean by higher solubility? Assume that, just an assumption, you have water. I will put a few crystals of salt and few crystals of sugar. Just an assumption. So when I start dissolving it with the same speed, I keep on stirring it, sugar dissolves. But salt will dissolve after number of stirring. See, what example I have chosen, both will dissolve at one point. Just an assumption and imagination, thinking that both crystals, when I 1 spoon of crystal, 1 spoon of sugar crystal and 1 spoon of salt crystal, if I am dissolving by stirring it in water, 5 times when I stir, for example, sugar is dissolved, right? But salt is taking 10 stirs. Understood the meaning? So solubility, which is more soluble, sugar is much soluble here. Similarly here, that is meaning as solubility in water, which can get easily dissolved or absorbed in water. So here, for example, red has more solubility. What will happen? Red color rises here. Then green. This is red. This is green and this is black. You can see that color layer actually. Not very easy experiment which you can try this at home, because sometimes sketch pen, ink or what you use, that might not be the purest one. This actually works out with the dye what we use it for our clothes, right? We color our clothes sometimes. That is a dye. So you can try with that in case if you have that, and if you have a good paper which can absorb water. Filter paper is the best one. You can also give a try with the tissue paper. But tissue paper, what happens, as soon as you dip that in water, that gets moisture. So try it since you have lots and more time at home now. This is chromatography technique. Now this is a simple technique to show you chromatography. Actually, chromatography is also used in the laboratories to separate the drugs from the blood. Now what drugs from the blood? Suppose if the blood has to be purified, or all the medicines, drugs, extra poisonous things, if it is there in that, that can be separated. And it is also used in separating the different components of colors in the dye. This is the method of chromatography, right? Do try this to your level, whatever best you can do it. Next, we'll move on to distillation. Now, you have been studying about distillation since your lower classes, but if you understand, this is the method used to separate the components of two miscible liquids. Now, funnel method, when we discussed, it was a method to separate two immiscible liquids. Immiscible is something which do not get mixed with each other. When I talk about two miscible liquids, it is something which get mixed with each other. What it can be? Alcohol and water are miscible liquids. Acetone and water are the miscible liquids. Now, acetone is our nail polish remover, what we say. So, please use distillation method to separate two miscible liquids. We cannot be trying this at our home because we do not have round bottom flask, nor we have this distillating column at our home so that we can try out this. This distillation method, when we use, there is some physical property. That means it is based on the boiling point of the given liquid. That means if I have to separate acetone and water boils at 100 degrees Celsius. We all know that, correct? Acetone boils at 56 degrees Celsius. Now, what is the meaning of this? For example, if I just take half liter of acetone and half liter of water, start boiling that at one point of time only, 56 degrees Celsius, acetone is boiled. That is the boiling point of acetone. 100 degrees Celsius is the boiling point of water. We all know that different liquids have different boiling point. So, distillation method is mainly used to separate two miscible liquids of different boiling point. If they have same boiling point, we cannot be using distillation method, though it is a miscible liquid only. Miscible liquids can be separated having two different boiling point, right? How is it carried out? Let us see. What is our aim? Our aim is to separate mixture of acetone and water. So this is basically a round bottom flask. What we have taken in the round bottom flask? We have taken the mixture of acetone and water, right? So this is the mixture of acetone and water. And here again a similar type of a test tube or distillating funnel is attached to it, and a condenser so that it can cool it, and a beaker which can collect it. What basically happens now? I start heating this, right? So when I start, I also keep a thermometer here. Why thermometer? To note the temperature, right? So once we start providing heat to this at 56 degrees Celsius, what will happen? Water will boil? No, water will not boil, but acetone will start boiling. Correct? If it will start boiling means it will start giving out the vapors. Now what will happen to these vapors of acetone? This will start moving through the distillating column, that is through the condenser, right? Water is not boiling until that point of time because 100 degrees Celsius water will boil. So 56 degrees Celsius, when acetone will boil, the vapors which will move here get started collecting in this condenser. What is the main role of condenser? To cool down. So when this vapors will pass through the condenser, this part here, condenser has a facility, a type, something where it can cool it. Now what will happen when a liquid cools again? So this vapors, not liquid, sorry, these vapors when they are there in the condenser, it will cool. So if it will cool, vapors are turned into liquid back. So what is collected in this? In this beaker, acetone is collected. So that means whatever amount of acetone was there in the beaker, it evaporated at 56 degrees Celsius, passed through this condenser, cooled down and then collected as an acetone in the another beaker. What remained in this round bottom flask? Only water remained in the round bottom flask. So this is the complete setup of distillation of separating two miscible liquids of different boiling point. That can be alcohol and water, that can be acetone and water. Now, you need not know the temperature of this, right? Because we know the temperature of water anyways. So, the question can be asked is, give an experiment to separate two miscible liquids of different boiling point. You can do the same setup. You can write alcohol and water. You need not mention the temperature. Why? Because distillation process itself is a process of separating the miscible liquids with a different boiling point. So now in today's class we understood chromatography, where we separate the components of the colors, and distillation, where we separate two miscible liquids, that is acetone and water, basically which has different boiling point. So in tomorrow's class we will be again discussing some more components, some more separation methods, say as about fractional distillation or decantation, crystallization, etc. In today's experiment or in today's separating methods, if you have any doubt, you can call on the same day of the video set.